everyone, welcome to a new video on AI World for You. In today's video, let us see what is meant by search strategy and what are the different types of search strategies in AI. So, what is search? Search is a class of techniques for systematically finding something. So, we all know that search involves something where we need to explore. So whenever we consider a binary tree or any maze kind of problems, we need to find something. So to find it, we use certain techniques and they are search techniques in AI. Suppose we have a combination lock system. This is a common example, so I have taken that. We need to try out different combinations like 9, 8, 6. Like that, if it is a 3-number series for a lock, we need to try different combinations to open it. Same way, when you are solving any Sudoku, there you need to try different possible combinations and go by logic and solve it. In reality, when you want to know where a person is, we go and search for the person, right? So if we are looking for him in the right place only, we can find the solution. Similarly, when our AI search technique, when the algorithm is getting executed logically and correctly, then only we will arrive at the solution. Now let us get into the search techniques and dive a little deeper in it. Why is search interesting? Most of the problems, in fact we can say all the problems related in the field of AI are to be searched. So consider any path finding or path planning problems and certain games. It could be single player games or multiplayer games. And in natural language processing, machine learning and genetic algorithms, everywhere we are using search algorithms. If you consider the 8 puzzle problem, even in the previous case when we were discussing about search strategies, I have shared that in the initial state, we may not have the numbers in sequence like this. But the goal state is that we should get the numbers as 1, 2, 3, 4, 5, 6, 7, 8 in a sequential way, leaving the space in between. So to get this, we need to go for n number of combinations. Further, if this is the initial state, there can be n number of combinations like 6 can go up, 8 can move to the right space, 4 can move left, 2 can come down. So those 4 possibilities are listed in this level. Same way, for each and every combination, there are more possible combinations involved. Here if we see 1 moving right and 3 moving left are the best choices. So there are many more combinations possible in terms of the traversal. Our search algorithms will follow a particular strategy and traverse through the search space to find the solution effectively. Coming to the properties of search algorithms, there are 4 important properties of every search algorithm which needs to be tested so that we can call a particular algorithm as efficient or not. So considering the first one, which is completeness, whenever our algorithm is able to give the result, it is able to execute the search and find the goal item, then we will call it as completeness. So if it is finding a solution, then we will call it as complete one. So algorithm is performing its search in a complete manner. That is completeness. Coming to the next one, optimality. So optimality means finding the solution in the best possible way. There may be n number of ways in finding a goal state, but which is the best possible way? That is optimality. So to find the best solution with the lowest cost, we will call it as optimality. Coming to the next one, time complexity. Time complexity refers to how long the algorithm is going to take to compute something. So if it takes a long time, then we say that the algorithm requires more time, so it is most time complex. And if it occupies very less space, then we will call it as less space complexity. So time complexity as well as the space complexity refer to how much time the algorithm is taking and how much space or memory the algorithm is occupying in order to compute something. So whenever a task is done, say for example, if we give a print option to our processor, and if we are closing the document immediately, still the document will be printed because it is stored in the cache or the temporary data allocated to it. So temporary memory location is there to store this information about the printed document. So even though if we close the document, still we are getting the output. Same way, the algorithm will store the result, the temporary result which is arriving after each and every step in a specific memory allocated to it, and then proceed with the next step. So each time the search space varies, the goal state does not change, but the search space varies, right? So the memory needs to be updated as each and every iteration is performed. So these are the 4 important properties of search algorithms. Coming to the different types of search algorithms, broadly we can classify search algorithms into 2: uninformed search and informed search. Uninformed, as the name suggests, there is no prior information given to the algorithm about the goal state. It will not know whether it is approaching the goal state, nearer to the goal state, or far from the goal state. Same way, it does not have any prior information or domain knowledge. That's why we are calling it as uninformed search or blind search. Blind does not mean that it does not work by logic. It just implies that it does not know exactly about the goal state and it has no prior domain knowledge. Still, it needs to carry out the search and find the goal state. Coming to the informed search, in informed, as the name suggests, the algorithm already has prior knowledge about the goal state and it can carry out its iterations and search based on the information. So once one iteration is completed, it can know whether it is closer to the goal or whether it is far from it, and how much will be the path cost if it reaches from this particular source to destination in one route. And it can compare with the cost with other routes as well. So the heuristic value or the estimated value to reach the goal node will be known to the algorithm. That's why we are calling this as informed or heuristic search. Under uninformed search, there are certain search techniques like DFS, which is breadth first search, DFS, which is depth first search, UCS, uniform cost search, iterative deepening depth first search, and bidirectional search. And coming to informed search strategies, we have greedy best first search, A star search, AO star algorithm, and we have hill climbing algorithm, iterative deepening A star algorithm, and simplified best first search algorithm, and simplified memory bounded A star algorithm. So this is just a brief about the search strategies, how our agent is going to move from the initial state to the goal state is what we are going to see, and each algorithm will behave in a different way to do this. To reach from the initial state to goal state, each and every algorithm has a specific pseudocode. So let us discuss about the various search strategies in the next video. Thank you for watching.